Aaron, Darren, Karen, Marin, and Sharon rode on a small train that has 5 cars that seat 1 person each. Marin sat in the last car. Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron. At least 1 person sat between Karen and Darren, who sat in the middle car. So if we draw the 5 seats of the train, we know that Marin sat in the last car, so we can put Marin here. And we don't have any information to directly place any of the other people. But we know that Aaron sat directly behind Sharon and that Darren sat in front of Aaron. So Darren would also have to be in front of Sharon because Aaron is directly behind Sharon. So then we have to place Karen. So if we think about where Karen can go, our spots would be here, 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 and here. But we know that Karen cannot be between Aaron and Sharon because Aaron is directly behind Sharon. We also know that Karen cannot be either in front of Darren or behind Darren because at least 1 person sat between Karen and Darren, which means Karen must be behind Aaron. So then it's MKASD. And we're asking who sat in the middle car. And Aaron is in the middle seat, which means answer choice A, Aaron. How many integers between 2020 and 2400 have 4 distinct integers arranged in increasing order? For example, 2347 is 1 integer. So we have 4 digits, and we know that the first digit has to be a 2 because we're between 2020 and 2400. So then we have to think about our 100ths digit. So if it was just between 2020 and 2400 as our condition, our options would be 0, 1, 2, 3, and 4 if you include 2400. But because it has to be in increasing order, we know that it can't be 0, 1, or 2, and it can't be 4 because our only option for 4 would be 2400, which is not in increasing order, which means our 100ths digit is a 3. So now we have to pick our 10s digit and our 1s digit. But because it has to be in increasing order, our options are digits between 4 through 9. To find which 2 numbers to pick here, we can use a combination because if you think about it, any 2 numbers that you choose from 4, 5, 6, 7, 8, and 9, there is only one way to make it increasing. So if you pick 4 and 6, it'll automatically be 4 and 6. So really, there's 6 numbers here, and we're doing 6 choose 2, which is 6 times 5, 2 times 1, which is equal to 15. So there are 15 ways to choose a way to arrange 4 digits in increasing order. So that's answer choice C. Ricardo has 20 coins, some of which are pennies, 1-cent coins, and the rest of which are nickels, 5-cent coins. He has at least 1 penny and at least 1 nickel. What is the difference in cents between the greatest possible and least possible amounts of money that Ricardo can have? So we know that we have at least 1 penny and at least 1 nickel, which means that we have 2018 remaining coins. To maximize the amount of cents in these 2018 coins, we would want them all to be nickels because nickels are worth 5 cents while pennies are only worth 1. So if that was the case, we'd have 1 penny and 2019 nickels. On the other hand, if we wanted to minimize the number of cents that he had, we'd want all of these 2018 coins to be pennies instead of nickels because pennies are worth 1 cent. So then we'd have 2019 pennies and 1 nickel. So we're trying to find the difference in values between these 2 amounts. So we know that we have to subtract this value from this one, which would mean we want to do 2018 nickels minus 2018 pennies. And we know that each nickel is worth 5 cents, so that'd be 2018 into 5 minus 2018 into 1, which is just 2018 into 4. And 2018 into 4 is 8,072. So that's answer choice C. Akasha's birthday cake is in the form of a 4x4x4 inch cube. The cake has icing on the top and the 4 side faces and no icing on the bottom. Suppose the cake is cut into 64 smaller cubes, each measuring 1x1x1 inch, as shown below. How many small pieces will have icing on exactly 2 sides? So, if we look at the picture, we can see that the pieces that have icing on exactly 2 sides would be here, 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 and these ones. Because if you think about it, this part will have icing, and then also this side next to it will have icing. But because there's no icing on the bottom, we can't say that these pieces are going to have 2 pieces of icing because there's no icing on the bottom layer. Instead, these corner pieces on the bottom will have the icing because of this and this, but none on the bottom. So that would be a total of 1, 2, 3, 4. So 4 into 2, because each of these has 2. And then if we look here, 1, 2, 3, all 3 of these will have exactly 2 sides of icing. And then 3 into 4, 1, 2, 3, 4, 12, 8, and 8 plus 12 is equal to 20, which is answer choice D. Zara has a collection of 4 marbles, an Aggie, a bumblebee, a Steely, and a tiger. She wants to display them in a row on a shelf, but does not want to put the Steely and the tiger next to one another. And how many ways can she do this? So the best way to solve this problem is by complementary counting, which is when you take the total number of cases and you subtract the cases that don't work. So the total number of ways to arrange 4 marbles would be 4 factorial, which is 24. So we know we have 24, and we want to subtract the cases that don't work. The cases that don't work would be when the Steely and the tiger are next to each other. So a way we can do that is by grouping the Steely and the tiger together. So if we think about it, we're now arranging 3 things: the Aggie, the bumblebee, and then the Steely and tiger as 1. So that would be 3 factorial. But we have to multiply by 2 because we could rearrange the order of the Steely and the tiger. So the Steely could go first or the tiger could go first, which would be 3 factorial times 2 for the number of ways to do this, which is 6 times 2 is 12. So the cases that don't work would be 12 of them, and 24 minus 12 equals 12. Answer choice C.